現在盡量讀好書，就申請移民才是最重要。因為唔係當地嘅居民，就交嘅稅都好重下，稅收好難生活，就
Hi everyone, we'll start in about 5 minutes. Okay, it's 10 minutes past, so I think we can get started. Welcome everybody to the first lecture of Software Process Improvement in semester 1 of 2021. I'm your lecturer for the course. My name is Christoph, and today we'll do basically a quick overview of what this course is going to be all about. We'll talk a bit about assessment and things like that. The slides will be available on my uni later today. Sorry I didn't get around to uploading them before, but in the future I'll try to get them up before the actual lecture time. You probably have seen this slide in some other courses already. So of course, like any other course at the university, we acknowledge and pay our respects to the Ghana people, traditional custodians whose lands we gather on. We acknowledge the deep feelings of attachment relationship of the Ghana people to country, and we respect and value their past, present, and ongoing connection to the land and cultural beliefs. Okay, so much about the Ghana people. Now let's start talking about software process improvement. Let me just double check that I'm recording this because I wanted to upload the lecture afterwards. Yes, I am recording, good. Good, software process improvement. So, just a few administrative details to begin with. This course, as you will all have noticed, has online lectures twice a week. You all managed to find the Zoom link, so that's great. The lectures are on Monday from 12 to 1, Wednesday from 9 to 10. Wednesdays. The Zoom link should always be the same, unless Zoom breaks or I click on something wrong. The Zoom link should always be the same. Of course, we have quite a few public holidays this semester. So, for example, next week there's no lecture on Monday because it's a public holiday, and I think there are a few more Mondays coming up later in the term, which are public holidays. I'll try to post an announcement every time so that you don't dial in for no reason. This course, as you will have seen in the university calendar, also has practicals. Practicals will only happen in the first 5 weeks. So in the first 5 weeks, you'll have practicals. Let me just see what's coming into the chat. Where can I find the lecture notes? The lecture slides have not been uploaded yet, but you will see that I'm sharing my screen at the moment. So you should be able to see the slides at the moment. Lecture slides will be uploaded after the lectures. Thank you. So there are practicals for the first 5 weeks only. These practicals will happen in person, except with one exception. So they will happen in room 462 in the Incarni Wardley building, which I'm assuming many of you already know that room. Practicals will be in person with one exception. There's one practical session that happens in Zoom, primarily for our remote students. All this information should be available to you. In case you have any questions about that, of course, feel free to email me. I'm your lecturer. My name is Christoph. I put my email address on the slide. It's also on my uni. And the practicals will be handled by our casual staff. Her name is Ines, and you'll meet her in the practicals. I believe the first practical session is tomorrow, but there are other practicals on, I think, every day of the week except Monday. Okay. I'm hoping this is all fairly straightforward. Most of the lectures will be live, just as this one. We might be doing a few pre-recorded ones later on, especially when we have the opportunity to invite some international guest speakers to give lectures to us. Because of time zone issues, I might do some of those pre-recorded rather than live. But all of this will be announced. And if there's no announcement, you can assume that we'll be doing live lectures, just as the one today. Okay, I wanted to give you, if I can get to the next slide here, hello. There we are. I wanted to give you a little bit of an idea, before we talk about assessment, I want to give you a little bit of an idea of what software process improvement and software process in general is about. So you'll all be familiar with the word process, which generally refers to what somebody does and how they do it. A process usually involves a bunch of tasks. It has inputs, it has outputs, it has people who do things, and it might have tools. And in short, a process is basically something where somebody tries to complete a task using some tool to transform input into output. So in the context of software development, that often means that you've been given a particular task to write a particular piece of code, and you might be using a tool such as an integrated development environment, an IDE, to transform this task into an actual piece of code. Tasks are often partially ordered. That's especially true in software development, right? If you're developing a big system, you'll have to, for example, build the basic infrastructure before you do advanced UI features, for examples. Tasks, inputs, performance tools typically have preconditions and they have postconditions. So a precondition could be that you can only connect to the database after you've set up a database, and a postcondition could be that, well, once the task is completed, you actually have access to a running database. As part of a software process, you often need to organize and coordinate who does what resources they have access to, when, where, why, and how. That's in particular true if you're building software in a larger context, right? If you're just building a tiny piece of software, you might be able to do it all yourself. You might be able to do all of this in a text editor or something like that. But if you're building something large, then you actually need to organize and coordinate who does what, when will they do it, so that you don't break changes at the same time. Where do you do it? Do you work in your own branch? Do you all share the same branch? How do you do it? And sometimes, why do you do it? So this kind of organization and coordination is in particular important in large-scale software development, and we'll see some of that as part of this course. I'll look at some examples of this throughout the lectures. So process modeling, software process modeling in particular, is the process of understanding, analyzing, and redesigning software development processes. And these sorts of models can be prescriptive, proscriptive, or descriptive. Prescriptive means that the model sort of dictate what should be done and how to do it. So a prescriptive model could, for example, be that you should never work on the source code unless you're working on a particular task related to that source code. So this could be in a large software development team where you have a long list of tasks that everybody needs to work on, and you need to assign yourself to a task before you start doing anything. That could be a prescriptive model. So it's really a model that says this should be done and how to do it. Another example could be related to testing, for example. A prescriptive model could say that you can never commit code to the repository unless you're also providing the related test cases. In different development teams, different software projects have different models. In some domains, testing could be very important, right? You might have seen in the news that we have a new rover driving around on Mars at the moment. You can assume that that one has been tested extremely thoroughly, whereas at the same time for software in other domains, like some mobile game, maybe testing isn't so important because the cost of a failure will be a lot less. Proscriptive models, fairly similar to the prescriptive ones, but a bit less strict. They are basically a model that says what might be done instead of what should be done. And then finally, we have descriptive models, and that's something we'll actually look at as part of this course, where instead of saying what should be done or what might be done, we're just describing what was actually done. So we're looking at actual data at an historic record to say what was actually done rather than telling people what should be done. Of course, there can be connections between these things, right? We can decide what should be done based on observing what has been done. there can be quite a few different kinds of models or representations of these models, and we'll look at some examples of those shortly. Narrative, semi-structured, graphic, formal. I think all of these words are fairly self-explanatory, so I'm not going to go into detail on those. Okay. This is a picture from, I think, around 1955. Don't worry, we won't be talking about 1955 for most of the lecture, but I thought it was an interesting, this is probably one of the first known software processes that has ever been actually written down. So back then, this is how many years ago now? Many years, 65, right? Jeez. So 65 years ago, this is what people thought a software process could look like. I don't think they even called it software at the time. It was called coding and system and things like that. But basically the idea back then was that you would start with an operational plan, then at the same time, sort of in parallel, you would specify the machine. That was really important back then. Today we assume that everything can run on pretty much any machine. Operational specification, that's something you would probably call requirements these days. Program specification, coding specification, then the actual coding happens. Then you do different kinds of testing at the parameter and at the assembly level. Shakedown is another way of testing, and finally system evaluation. So quite a few specifications and quite a few testing and evaluation steps towards the end. As you can also see from this very old picture from the 1950s, programming was almost seen, or it was seen as a linear process, right? There's not a single arrow that goes backwards in that picture. All of them go from top to everything before you start implementing something, then you implement it, and then you test it, and that's sort of the end of that software development process. Of course, that's not really something that happens in reality these days anymore. Maybe it happens for the Mars rover, but it doesn't really happen for everyday software, like the kind of software systems that we all interact with on a daily basis, because the 65 years since this picture have shown us that it's unrealistic to assume that we can perfectly specify a software before we start writing the first line of code. And that then has given rise to basically this sort of contrast in software development processes, I guess. There are many intricacies to both of these, but I don't want to go into a lot of detail on these today. And I'm assuming you'll also have heard of this in previous courses. But of course, one of the big distinctions in software development processes is this idea between waterfall and agile, where waterfall implies that you don't really go backwards. So you start with the requirements, then based on the requirements, you create the design. Based on the design, you implement, then you do test, and then you do maintenance. And you never go backwards. That's unfortunately not realistic. And that's what maybe around 20 years ago has given rise to agile methodologies, where you basically go through all of these steps in very short cycles, often like 2 or 3 weeks. So you do some planning, some defining, some design, some testing, some deploy, all within a few days, and then you start the same thing again. So you sort of take it one feature at a time. Ideally, you work with the customer the whole time so that you can always be sure that what you have developed, what you have deployed, actually meets the needs of the customer. So that's sort of the very big picture of waterfall versus agile. If you have some time, I would recommend you take a look at this link. The link's at the top of the slide, and just mentioning this again, the slides will be available later today. So this is a slide that shows all the, and this list is probably not even complete, but it attempts to show all the different aspects of agile processes. And I have to admit, even I don't know what all of these things mean. On the website, they are all linked, so you can look up what they all mean if you're interested. But the point that I want to make with this slide is that modern software development processes have a lot of these intricacies, and not all software development teams follow the exact same process. So user stories, for example, that I see there on the top right, it's a pretty common thing that the 3Cs, for example, are less common. That's related to continuous integration and so on. Automated build is pretty common. Scrum of Scrums is probably a bit less common, and so on. So what I want to just say with this slide is that modern software development processes are quite complex, and they are probably more complex than voice lag in a while. Sorry, okay, we seem to have a bit of a lag here. Let me see if I can switch to a better network. How do I make myself? Just a second. Let's see if I can find a better network here. Okay. Has the audio gotten any better now? Trying a non-university network. Sounds fine so far. Okay. Yeah, let me know on chat if it breaks again. So anyway, the purpose of this slide was just to show that agile development is more than what I showed on the previous slide, where we just have the circle of requirements, design, implementation, testing, deploy. There are actually a lot of intricacies to agile, and not every software project, not every software development team uses agile in the same way. But yeah, if you're interested in that particular, I encourage you to take a look at this website. But what I really wanted to do today, that sort of will lead us into how we're doing the assessment for this course as well, is sort of where challenges are these days with relation to software processes. One thing, and maybe in particular now in times of the pandemic, that's become even more important again, a lot of software process challenges are related to the fact that software development tends to be distributed, decentralized, and or global, which basically just means that the people who contribute to a software project tend not to be in the same place, right? And these days, even if we live in the same city, we tend to not be in the same office. But even if it's not for that, right, big software projects are usually developed in many different cities and many different countries, and people need to work together across time zones, across long distances, and figure out how to effectively collaborate across all those boundaries. So that's a big challenge for software processes, because if you can't see the people that you're working with all the time, planning becomes much harder. Process improvement is always a challenge of the course, of course, software process improvement. As you could probably gather from the previous agile techniques, many software development teams, many practitioners have tried to come up with all sorts of ideas to, let's see what it's breaking again. Okay, I'm not sure I have a better internet connection here. It's always going to make. Welcome to UDP, yeah. Okay. Yeah, I'm not sure I have a better internet connection than this one, because I have to do lectures from home. Just continue. I don't think it will get better. Yeah, sadly, I agree with that. Okay. So, as you could see on the previous slide, lots of practitioners have come up with all sorts of ideas how to make. Previously, it was better. Okay. Let's see if this works better now. So people have come up with all sorts of ways to improve the software development process, because nobody probably has found the best way of doing this yet. A big challenge is also just articulating how you do software evolution, because as you again could see on the previous slide, there's such a zoo of terminology now in the agile world, for example, and the same would apply to other software methodologies as well. And you might also have heard that some companies say they are doing agile, some companies they say they are doing some flavor of agile, which then leads to this whole box of weird methodology and terminology around how you would even describe what a software development process looks like. Open source software development process is a particular interesting area, and that's what a big part of this course will actually focus on. And then we have process discovery, which basically means that instead of prescribing a particular methodology, you look at existing software processes and try to understand, try to discover what they do, what they look like, and so on. Okay. Okay. So with that, I wanted to talk about assessment, but I thought I'd just give you a very quick intro on what sort of challenges we're facing in regard to software processes, so that you understand where the assessments come from. So, as I said, this will be posted later today. We have 6 assessment components in this course. The first one, which will probably be due around sort of the early to mid part of the semester. I'm thinking week 4, week 5, which will be an analysis of existing contribution processes. So that fits in with what I was talking about on one of the previous slides regarding process discovery. And in particular, what I will be asking you to do is to look at an existing open source project, or maybe multiple open source projects, and try to discover how people have gone about contributing to these projects. What processes do they follow? So in this case, we're really taking a descriptive approach. Instead of telling them how they should be contributing, we're analyzing how did they actually contribute. This will be a short essay, I'm thinking 2 pages with a bit of a timeline. All of this will be detailed on MyUni over the next couple of weeks, and that one will be an individual assignment. The next 2 parts sort of go together. So as part of the project, I'm going to ask you to work in small teams, 5 to 6 students. I'm going to ask you to work in small teams to make a contribution, to sort of go through the entire contribution process for an open source project. And don't worry, you don't have to find the open source project on your own. I will be giving you some ideas in that regard. And the assessment of that is basically coming in 2 steps. The first one is I want you to come up with a proposal, what you're going to contribute, what project you're going to contribute to, and how you're going to go about doing that. And the second part is to actually do the contribution. The first part will be due around mid-semester, the second part at the end of the semester. Actually, the next assessment component also plays into this. As part of the teamwork, we'll be asking you to use Slack for at least part of your team communication, and we'll take a look at that for assessment as well. At the end of it, at the end of the semester, week 13 or so, we'll have an essay due, basically reflecting on your experience of trying to make a contribution to an open source project, in particular from a process point of view. What were the different steps that you had to follow? What surprised you in how you had to follow these steps? What worked well, what didn't work well, and so on. So basically reflecting on the experience. And on top of that, we'll have a couple of quizzes that in total will be worth 10%. Some of those might be done as part of the practicals as well, but they'll all be done through MyUni. Okay, as always, as in other courses as well, I guess you are expected to participate in all activities, attend lectures, and submit your assignments on time. Before I go to the next slide, which is sort of the generic assessment slides, I just want to give you a minute in case you have any questions about any of this at this point. I will be posting more details on all of these aspects once the assignments are out. Do we have any questions about anything on this slide at this point? Can you please explain? Yes, there are practicals. I had those on the first slide. So practicals are for the first 5 weeks only. You should all be enrolled in exactly one practical. If that's not the case, please email me and we'll try to figure this out. There will be coding in this course, yes. Programming language to some extent is up to you because I'll leave it up to you to select an open source project that you want to contribute to. The one that I'm recommending is written in Java, so in that case the programming language would be Java, but if you'd like to work in a different programming language, I'll help you to find an open source project that's written in the programming language that you would like to work in. So just to go back to the question about practicals, there are practicals. The practicals don't have a programming language. For the practicals, we'll, oh dear, lots of questions now. Let me make the chat window bigger here. The practicals will be focusing on understanding all features available in GitHub, not just the basic ones, but will sort of push the envelope on all the features on GitHub. Programming language doesn't matter there as much as being completely comfortable at the end of the practicals with GitHub and Git, basically. So no programming language in the practicals, but lots of experience with all aspects of GitHub and Git in the practicals. Some people would call Git a programming language, so maybe you can think of it as that. So yeah, practicals for the first 5 weeks only. You should all be enrolled in exactly one practical, most of them in person in Nkani Wardley 462. One of them is online for our remote students. Will there be any coding involved in the practicals then? Do you consider command line use of Git coding? Then yes, otherwise no. And coming back to the question at the beginning here, can you explain assessment 1 again? Yes. So for assessment 1, I'll send out more details either by the end of, I'll try to get it out by the end of this week with due dates and everything. The basic idea is that you look at a couple of open source projects. I'll give you some ideas for projects that you can start with, and you try to understand what steps somebody needed to follow to make a contribution to these open source projects. So for example, in many cases, contributors start by maybe the first thing that they ever did is report a bug against the project. The second thing they might do is fix a bug in the documentation. The third thing they might do is actually contributing to the source code of the project. So it often goes in a few steps. And what I'd like you to do for the first assessment is analyze a few existing contribution processes that you can see on GitHub and actually write down, describe how people have contributed to an open source project. And I skipped over Kate's question. Let me get to this now. Are we going to select members by ourselves? What I was planning to do, and because I haven't done it yet, feel free to push back on this if you really don't like it, but I found that works reasonably well in other courses. What I was planning to do was that I do the assignment of the groups, but then I allow you to switch with each other. So basically, I assign teams of 5 to 6 people. I'll probably aim to have a bit of a mix of stronger and weaker students based on past assessments and so on. So I'll do the first assessment of the teams, but then if you feel strongly that you want to work with other people, then it would be your responsibility to find somebody else that you want to switch with. That has worked reasonably well in other courses that I've taught so far. If you feel strongly against that, we won't be assigning teams until, I would say, at the earliest in week 3. So I'm still open to discussion around that. Yes, Liam has a strong team of 6 mates. I'm sure everybody would want to be part of that strong team. Look, I'll think about it. If anybody else has feedback on this, what if we get our own teams? Yeah, exactly. That's the point, right? So if I do the allocation of teams of 5 or 6, then we definitely know that everybody has a team. And if you manage to switch with each other, then maybe you manage to find the team with all your mates. Yeah, if you have strong opinions about this, feel free to post in the forum on my uni as well. I won't be assigning students to teams until week 3. Surely assign teams to the people that don't. Yeah, so I guess that would be an alternative as well, to give students some time to create teams, and then all those that aren't in teams by a particular date, I could then assign. Okay, I'll think about it. I'll have a decision on that at the latest by next week, and then we'll start assigning students to teams by week 3. Okay, I feel like I've missed some question. 5 practicals for the first 5 weeks, so 1 practical per week. That's correct, yes. Okay, regarding is each prac worth 2%? No. So we'll have the main purpose of the practicals for this course are to get everybody up to speed and really comfortable with all the features of Git and GitHub to the extent possible. Because once we want to get to the stage where we can contribute to an existing open source project, we want to make sure we don't get bogged down by maybe not fully understanding how Git and GitHub work. So that's the purpose of the practicals. The purpose of the practicals is not assessment. Having said that, I reserve the right at this point to put some content from the practicals into the review quizzes, which in total will be worth 10%. I hope that answers that question. I think I missed Fan's question here. Will these existing contributions be applied to us? I'm not 100% sure I understand the question, but basically assessment 1 is about analyzing existing contributions from other people from outside this course, professional software developers. And then assessment 2, 3, 4 is about you and your team making a contribution to an open source project. So we have one aspect, so the first assignment, understanding other people's processes, and assignments 2 and 3 there, making your own contribution to a project. Okay, I like to think I've caught up on all the questions that came through on chat. If I missed one, please post it again. Okay. So these slides you've probably seen already. So as all courses, or most courses at the university, we have HD, D, C, P, and F, and some things for 0%, which I'm hoping none of you will get. So this is all standard. I decided that we will have no hurdles in this course. So at the end, we'll just sum all the marks for all the individual assignments and team assignments up, and that's your final mark. There's no requirement to achieve at least 50% or whatever on any of them. As long as in some you get above 50%, you will pass the course, which I think will make assessment a bit easier. The late submission policy, I believe, is pretty standard. Up to 1 day late, we're capping you at 75%, 2 days late 50, 3 days late 25, and more than 3 days late, we go down to 0. Repeating students, I want to say something about that because the course has changed quite a bit from last year. So if you are repeating a course, if you are repeating this course, chances are you won't really recognize the course because it's changed quite a bit. If you are repeating the course and you think there is some previous assessment that you would want to be counted, please get in touch with me by email as soon as possible. Okay, extensions, this is all sort of the standard text. Extensions, unfortunately, I can't grant it extensions just for the basic fact that you're asking for one. However, if I do get if you can send me some excuse, ideally with some sort of documentation for me to grant an extension, then I'll be the last person not to do this. And we also all realize that because of the ongoing pandemic, of course, we're all dealing with additional stress factors that we don't usually have. So basically, long story short, if you're asking for an extension and you can give me some reason for it, I'll probably say yes. But don't ask for an extension without giving me any reason. We can't really start giving extensions where we don't have any reason to do that. That's a question. I want to confirm that Java is used in that GitHub project. There are definitely lots of GitHub projects that use Java. You are free to select whatever GitHub projects you like to contribute to as part of this course. So you could pick one that is not written in Java, or you could pick one that is written in Java. Are the practicals formative, as in will we get a mark as long as we submit our work? There is no assessment specifically for the practicals. The point of the practicals is really just to get you up to speed on using Git and GitHub. There will be no submissions in the practicals. The casual teaching support will try to help you all get up to speed on Git and GitHub, but there will be no submission marks as part of the practicals. Okay, a couple more details for extensions on the slide. Of course, if you don't like my decision on whether to grant you an extension, you can always talk to the head of school about this. Additional assessment, I believe all of you should be level 2 and above. Actually, the course is level 2 and above, so this slide should count. If your final result is in that 45 to 49 range, then an additional assessment is automatically granted. Because we do not have an exam in this course, this additional assessment is obviously not an exam, but I will be happy to come up with an additional assignment. Realistically, the assignment is probably going to be a slightly varied version of the first assignment that I mentioned a few slides ago. So that will apply to you if you have a final result in that 45 to 49 range. Okay, I'm pretty sure you've seen these slides before in other courses, so I'll be fairly quick. We have strict policies regarding academic honesty. I do know how to use Turnitin, so don't, blatantly copy each other's texts and code and things like that, whatever you might submit. Plagiarism is using another person's ideas, design, words, or works without appropriate acknowledgement. If you want to use other people's stuff, acknowledge that. And collusion is another person assisting in the production of an assessment submission without the express requirement or consent of the assessor, which will be me. Basically, do not submit any work or part thereof which is not yours, and do not submit any work for which you have received unfair assistance. I don't think I need to go through these examples in detail. If you'd like me to go through the examples in detail, feel free to send me a message on chat. I think the really important point is there, when in doubt, ask your lecturer. So if you're not sure whether something would count as plagiarism, whether it would count as collusion, whether it would count as something else, ask me, and chances are we can, work out something. Maybe it's just maybe it's just a matter of acknowledging the source where you're taking something from. maybe it's a matter of, if it's part of teamwork, maybe it's a matter of politics inside the team. I realize that often these cases aren't, black and white. And if I know that you're planning to do something beforehand, we can work it out. If I only see it after you've submitted something and, Turnitin tells me that two assignments are exactly identical, then there's very little that I can do at that point anymore. Okay, that's all I wanted to say about the assessment part. Because we only kind of have 10 minutes left, and there's another message in chat. Okay, that's a good question. Can people enrolled in the regular undergrad version of the course 4023 join a group with people enrolled in the honors version? Yes. And the same applies to the postgraduate cohort as well. So for the creation of the teams, I do not care which version of this course you're enrolled in. Happy to have teams made up of, 2 master's students, 1 honors students, and 2 undergrad students or something like that. Happy to have any sort of combination there. In particular, because I think we only have a relatively small number of honors students, so 4123 enrolled in the course. Chances are they wouldn't be enough to form a team on their own. But yeah, there's absolutely no requirement from my perspective that that students need to come from the same course number. Okay, I hope that answers that question. Because we don't have a lot of time left in this lecture, I might actually leave the lecture material at that. And what I'd like to do is to ask you a couple of questions, just so I get a better idea of what sort of background you already have. I'm not sure if you've used this poll maker before. Let's do this very quickly. What experience do you have with open source? I don't know what open source is. I have used open source projects. Those projects I have contributed to open source projects. I have started my own open source project. Okay, so I'll put the link in the Zoom chat here. If you could just take a minute to answer that question in the link that I just posted in the Zoom chat, that'd be great. Then I'll get a better idea of how much experience we already have here. Oh, sorry, I posted it to the wrong person. I'm sorry. Let me try this again. Just a second. There we are. Now you should all have access to the link. So I'm just trying to get a feel for how much experience you already have with open source. Basically, at what level we want to start. Do we want to spend some time defining what is open source, or has everybody created their own open source already? Open source projects. Let me refresh this. Okay. So far, can I show the numbers? Okay, yeah. Okay. Thanks everybody for responding. That's a fairly good response rate here. You have 25 people responding already. Good, thank you. Let's see if we get some updated stuff here. Okay, now we're above 30. Cool, so some people don't know what open source is. We'll fix that in this course. It's good to see that many of you have used open source before. We will be talking about specific open source projects as part of this course as well. One person has contributed to an open source project already. My hope is that by the end of the course, all of you will be in that third bucket there, that you have contributed to open source project. And actually, as part of the pracs, you will also set up your own open source project. You will set up your own project on GitHub. just so you can see how to do that. You can get the right documentation in place, and so on. Cool. So let me just refresh this again. Yeah, trend, I'm assuming, will stay the same. Cool. Thank you. And then the other question that I had, let's do one more and then we'll wrap it up for today. The other question I had was about what experience do you have with GitHub at this point? GitHub. What is GitHub? What would be the next good option here? I have downloaded stuff from GitHub. I have uploaded stuff to GitHub. I some projects. Okay, let's just quickly do this again. And this is the link for voting. Thank you very much. So I'll open the results page. Okay, so at least the initial numbers seem to suggest that we have a good amount of GitHub experience in this course already. Okay, that's good. That's good to see. So we can probably cover content related to sort of the basics of GitHub fairly quickly in the practicals then, because it seems that quite a few people are familiar with GitHub already. Good. We will, in the practicals, try to push the envelope quite far with making sure that you're all familiar with pretty much all features of GitHub. But that's good then, we're starting at a fairly good level. People have downloaded, people have uploaded, people own projects. Maybe just a quick question, feel free to just answer in the chat. Is this mostly from other courses at the university, or is this stuff that people have done on their own? Maybe I can just get other courses. Okay, good. Other courses on my own, both. Okay, thanks for the answers here. Okay, cool. Cool. We still have a few people who don't know what GitHub is, so we'll cover that as well. Yeah, like I said, the role of the practicals in this course will be to get everybody up to a really comfortable level with Git and GitHub. Because once we get to the stage where we actually want to make a contribution to an open source project, we don't want lack of knowing the tooling to be in the way of us making really good contributions. So at that point, you should all be very familiar with GitHub. And something that we can do in the practical, something that we will do in the practicals, is sort of play around with all different ways of creating conflicts with each other and things like that. So yeah, we'll try to create conflicts on purpose, and we try to resolve those conflicts. We'll try to play around with all the different aspects of code review that GitHub has implemented in the meantime. GitHub sort of keeps adding new code review features on a at least yearly basis, if not more often. And actual open source projects use all of them, so we want to be familiar with all of them. Right. Thanks for responding in those surveys. Where we have 1 minute left. Any last minute questions? Eclipse versus IntelliJ versus VS Code. All of these are good IDEs as far as I'm concerned. Again, for the practicals, it'll be mostly the, we'll start with the GitHub web interface and then a command line client for Git. Whether you want to integrate that into your favorite IDE is up to you, and we will not be prescribing a particular IDE here. Paint is good, yeah. All right. Seems like we have gotten to the end of the first lecture here. Thanks, everyone. We'll have another lecture on Wednesday morning. We'll start at 10 minutes past 9. And in the meantime, I'll upload these slides I'll upload these slides to my uni, and yep, we'll be in touch. See you again on Wednesday morning. Thanks, everyone. Oh yeah, and the recording of this will be available on my uni as well. All right. Thanks, everyone. Have a good rest of the day.